Very good evening, class. How are you? I hope all good. You are all learning very well. Keep study, keep learning. So today I am going to take a very important lecture on the chapter that is neural control and coordination, and the subtopic is generation and generation and conduction of nerve impulse. Okay, so point to be noted here: generation and conduction of nerve impulse. Let's see what happened here. Okay, so my heading is subheading is chapter name is control, neural control and coordination, and subtopic is generation and conduction of their nerve impulse. So generation and conduction of nerve impulse. Nerve impulse. In this heading, you people have noticed, in this heading there are two words have very importance. Their importance. What kind of importance? One is generation and second one is conduction. So one is generation and second one is conduction. When the impulse has been generated, when the impulse has been generated, it will be conducted. Okay, when the nerve impulse will be generated, then the conduction will move on. So question is here, how to nerve impulse is generated. The question is that how to nerve impulse has been generated. Let's see. Before continue this topic, before continue on this point, I'm expressing my word about the neural. What neural? Point number one, that neuron, as we know that neuron are excitable cell. You know that very well. Neuron are what? Excitable cell. So neuron are excitable cell. Neuron are excitable cell. Neuron are what? Excitable cell. Neuron are excitable cell. Got it? No. Neuron are excitable cell and what? Why it is neuron? Why it is excitable cell? Anyone? Okay, very good answer. Good. Very good. Because their membrane are because their membrane are in polarized state. Membrane are in polarized state. Got it? Now the second point, difference. Now the second point is different type of ion channel are present. Different type of ion channels are present here. Different type of ion channels. Different type of ion channels are present on where? They are on membrane. Present on neural membrane. Present on their neural membrane. These ion channels are positive or negative. These channels are ion channels channels are selectively permeable to different ions. Selectively permeable to different channel, different ions. Got it? No. What I have right here, we are studying neural control and coordination, and the subtopic is conduction and the generation of nerve impulse. Before continues this point, here are two mentioned words, two specific point we have to discuss with you people. One is neuron are excitable cell. Why neuron are excitable cell? Why it is excitable cell? Because they are membrane in a polarized state. Neuron membrane has been what? In polarized state. And there are so many different type of ions channel are present on the neural membrane, where it is a selective permeable to different channels, different ions. Means there are positive ions and there are negative ions are present here, but it is depend upon the condition. Which condition has been arrived here. So on the behalf of that condition, the ions and the neural and the ion channel will be open. Got it? Okay, so before continue this lecture, we have to discuss some type of channels. Which kind of channels are present here? Normally, I have mentioned here there are ion channels are present on the membrane, on the neuron membrane. So the question is normally arise ki how many type of channels is present there. Sometimes it is 2 type, 3 type, 4 type, or what type. So must be a point mentioned here that are the different types of channels. So point is ion channel. Type of what? Type of channel. One is leakage channel. Type of channel. Type of channel. Number 1, leakage channel. What leakage channel means? What leakage channel means? Sodium and potassium and sodium. And leakage for what? Means always open. For which? Always open I'm here comparing. Potassium is much more open than sodium. Point number 1. Second one is VGA channel. VGA means voltage gated channel. Voltage gated channel, or VGA. Voltage gated channel. VGA. It is open for calcium, sodium and potassium. Calcium, sodium and potassium. And opening of VGA depend upon opening of VGA is depend upon what? Depend upon membrane polarized. Not polarized, you can mention the membrane potential. Membrane potential. Third one is ligand gated channel. Third one is ligand gated channel. Third one is ligand gated channel. That ligand gated channel for chlorine and sodium. Ligand gated channel, chlorine and sodium. Opening of ligand gated channel is depend upon opening of ligand gated channel opening of ligand gated channel is depend upon binding of ligand. Binding of ligand. And last one is mechanical gated channel. Last one is mechanical gated channel. Mechanical gated channel. It is only for sodium. So this point is mentioning here, and try to focusing here of you people that there are 4 type of channels present. One is leakage channel. Most common leakage channel is it is only for the sodium and the potassium, and always open for the sodium as well as potassium. But here point is mentioned, focusing point is potassium has much more efficiency than the sodium. Okay. The second one is voltage gated channel. Voltage gated channel is for calcium, sodium and as well potassium, and it is the VGA is depend upon the membrane potential, means how much amount of potential has been arrived on the behalf of potential on membrane. It will be open or close. Now third one is ligand gated channel. Ligand gated channel is for chlorine as well as sodium, and it is depend upon the binding of the ligand. And the last one is the mechanical gated channel. It is only for the sodium purpose. Got it? Okay. Now the mechanism of conduction of nerve impulse. Now point is this. Point is mechanism of conduction. Mechanism of conduction. Mechanism of conduction of nerve impulse. Of nerve impulse. How impulse has been generated or conducted. One is point here, number one point is resting or polarized state. Resting or what? Polarized state. Resting or polarized stage, phase state, whatever, phase. On resting stage, the resting membrane potential is -70 millivolt. It is fixed and mentioned in NCERT also. Okay. So RMP means what? Resting membrane potential. is minus 70 millivolt. Point to be noted here. And permeability. What about the permeability? What about the permeability? What do you think about the permeability? Anyone? Yes, good. Permeability about two. One is potassium and second one is sodium ion. Potassium permeability is more, and on the other hand sodium permeability is less. What is the meaning of this one? What is the meaning of this point? Meaning is very simple. When the membrane has been polarized state, the ions channel are present on that membrane. In that case, in that phase means resting phase. In resting phase, potassium ion can be leaked. Potassium ion can be leaked, can be outside, can be go to outside. But sodium entry has been totally blocked. Means potassium ions moving, potassium ion can move outside the membrane, but sodium ion has been fully blocked. Means this, no sodium will enter in the membrane. Got it? Okay. Now I am presenting this point on the behalf of in a diagram form. So diagram form is what? No noise, please. Focusing on study. Suppose this is a membrane and these are the ions channel. Got it? Okay. Outside environment is positive. Outside environment is what? Positive. And inside environment is negative. Inside environment is negative. Means what? This means is inside of the membrane that there are so many potassium are available. There are so many potassium are available. There are so many potential are available. And outside there are too much sodium are present. Sodium ions are present here. When we check the volt of this membrane by the help of voltmeter, when we check the voltage of this membrane by the help of voltmeter, so the membrane potential has been found minus 70 millivolt. It has been observed by the voltmeter, not randomly I am presenting here, or the neither books. Okay, this has been polarized stage. What polarized stage? In a nutshell, in a polarized state, RMP, resting membrane potential is minus 70 millivolt, and and permeability. Potassium has more permeability, and the sodium has less permeability. This is the diagram of this one. Here you can see the outside environment has been positive, and the inside environment of the membrane has been negative. While membrane potential has been observed -70 millivolt by the help of voltmeter. Here sodium can be moved outside. Here, sorry, potassium can move outside. Potassium can move outside. Few potassium, not all. Few potassium can move outside, but sodium entry has been fully blocked. No, this means is not a single sodium can enter inside the membrane. This is the simple meaning of this one. Okay. Now second point is action potential. Now second point is that action potential. Got it? Second point is that action. Acha, what is this? This is sodium ion channel. This is sodium potassium channel. Mention here. Okay. Sodium potassium channel. Not channel, pump. Sodium potassium pump. We will discuss, not here, later. Now the second point is action potential or polarized stage. Second is action potential or polarize. Sorry, polarize, not depolarize. How could you depolarize? Action potential stage. What do you mean by action potential? Means some impulse has been arrived. Let's take a very simple example. Suppose this is the plasma membrane, and outside ions are positive, and inside ions has been negative. Okay, and this is the channel. The potassium channel potassium channel is open. Okay, so potassium can be moved out. Not all, few. Okay, but sodium entry has been fully blocked. This is the simple. Okay, now action potential time. Some impulse has been arrived on action and on plasma membrane. So when the action potential when the membrane potential has been arrived on membrane, so RMP will be disturbed. How much? This is the point. So I think action potential can be described by the help of diagram better. So try to make a diagram. Okay, diagram will finished. And now the point is action potential has been arrived, impulse has been arrived. So the when the impulse has been arrived now, so in what, in membrane there are suddenly change, what kind of changes has been occur here, let's see. This was the previous environment, now action potential has been arrived, now potential impulse has been arrived, impulse has been generated. Impulse can be generated by so many ways. ये मैंने pinch किया like this, so potential has been generated. You feel na? You feel, yes. So potential has been generated. So sodium ion, potassium ion, and here one sodium ion. Here one potassium ion. Here one potassium ion. So channel will be open. Look, and the next phase channel will be open. So here was what? Here was potassium, sodium. So it was open and enter to where? Inside the membrane. Enter to where? Inside the membrane. Now sodium is entered. Now sodium has been entered. Now when the sodium has been entered, the membrane potential will be changed. Membrane potential will be changed. So potassium will be changed. How potassium will be changed? How the membrane potential will be changed? Look, earlier it was 70 millivolt. Yes or no? Yes. Now it will be reduced, minus 60 millivolt, minus 50 millivolt. Later on it will be 0 millivolt. Yes or no? Yes. And later it will be converted into 10 millivolt. Later it will be finally converted into 50 millivolt. The membrane potential is changed like this. When the sodium entry will be open and the sodium enter one by one, the membrane potential will be changed depending upon the number of the sodium ions. Yes, potassium ion will move. Potassium ion will also move, but not much more. Why? Because the sodium channel has been opened and sodium is continuously putting down itself. Got it? Okay. Now the membrane potential has been changed. Minus 70 millivolt has been converted into plus 50 millivolt. There are so big changes as the information come here. I mention here as information comes. Information means impulse. Information comes, sodium channel is open, and threshold potential will count here. Threshold potential that is minus 60 millivolt. This is an important point. And now the action potential is plus 50 millivolt. Now action potential value is plus 50 millivolt. Got it? Now, repolarization. Now repolarization, third stage is repolarization. Repolarized state. What happened in repolarized state? What happened in repolarized state? There are sodium channel will be open, sorry, potassium channel will be open. Point 1. In repolarized state, potassium channel will open and different ion concentration will create. And different ion concentration will created, is created or developed, whatever. So when the different ion concentrated is created, so how it will be improved? How it will be improved? Until it will not improve, so mechanism has not completed here. So how it will be improved? So for improving this point, we use the sodium-potassium pump. For improving this point, we use improved by sodium-potassium pump. Now we use what? Sodium-potassium pump. Got it? Got it? Let's see the diagram. You will understand all the things. This is channel. Here is positive. Here is negative. Got it? Got it? Yes or no? Okay. What's happened here? Potassium ion, it's move out. Potassium ion is move out. RMP is plus 50 millivolt. RMP is what? Plus 50 millivolt. Here is potassium. Here are so many sodium ions is present. So many sodium ion has been present. And rest of sodium ion is outside, which cannot enter. Why? Because the channel has been blocked. These sodium ion wants to move, but due to the blockage of channel, it cannot move. Got it? It cannot move. So what will be happen here? Here the sodium potassium pump will work. Let's see the sodium potassium pump. It will be catch 2 potassium outside and 3 sodium inside. It will be catch, this sodium potassium pump will catch 3 sodium ion from inside and 2 potassium ion from outside. After binding this ions, it will be what? It will be what? It will be rotate. It will be rotate until the membrane has been polarized. Until membrane has been polarized. Got it? Membrane has been polarized. Now the RMP will convert slowly. Plus 50 millivolt. It will be converted 20 millivolt. It will be converted 0 millivolt. Now minus 10. Reach out minus 7 millivolt, and sometime it move on minus 80 millivolt also. It will move on minus 80 millivolt also. It is totally depend upon the sodium potassium pump. Sodium potassium pump basic function is collect the 3 sodium ion from the inside of the membrane, and that collect the 2 potassium ion from the outside of the membrane and reflect and rotate. It has been rotate again and again until the action potential membrane will be minus 70 millivolt or much more, means minus 80 millivolt or minus 90 millivolt. Okay, so this mechanism is known as conduction and generation of nerve impulse. Let's see, try to understand this mechanism by the help of graph, because the question will be arise from the graph, and the NEET examination, NEET authority will ask you the question from by the help of graph. So graph is much more importance as compared to this one. So let's see the graph. Let's see the graph. Suppose this point is minus 70 millivolt. Got it? This point is minus 70 millivolt. Okay. This point is not this one. Try to make this point. Suppose this point minus 70 millivolt here. Got it? The impulse is resting. Impulse is resting or not? Impulse is resting. Of course, at minus 70 millivolt, the impulse has been resting. That is polarized state. Suddenly, impulse has been arrived. Suddenly, impulse has been arrived. So it will be move. It will be move. Minus 60 millivolt. Minus 60 millivolt. Later on, it will be shifted to upward. Suppose this one is 0 millivolt, and suppose this one is plus 50 millivolt. So impulse has been arrived to onward. Got it? Let's see. This is the polarized state, yes or no? This is the resting phase, yes or no? Resting phase. So here you would mention this is the resting phase. This is the resting phase. This is resting phase. From here to this point, this changes is minus 10 millivolt. The difference of this one is minus 10 millivolt. This is called actual threshold value. This is called actual threshold potential. This point is called threshold potential. Here I am writing. Potential. If the question is asked by you or asked by the NEET, what is the threshold value? So threshold value is minus 10 millivolt. And what is the threshold potential? The threshold potential is minus 60 millivolt. Got it? Threshold value. Now it has been arrived. It has been arrived. So when it will be arrived, so this phase is called depolarization, bachcho. Depolarized stage. Depolarized stage. What happened in depolarized stage? Sodium ion entry is start. Sodium ion is entry has been what? Start. Now it's peak. Peak. Where? Till plus 50 millivolt. Plus 50 millivolt. Here. This is the peak point where sodium channel has been closed. Sodium channel has been closed. And this is action potential. Now it will be reback. Now it will be reback. After now it will be reback. So how? By the help of sodium-potassium pump. So here you can mention this is the action potential point. Action potential point. This is the action potential point. Now on this point, sodium potassium channel will open and it will be drop. This is called repolarization. This is called repolarization. This is called repolarization. And suddenly it comes to same point, minus 70 millivolt. But sodium potassium pump does not know how much amount of sodium as well as potassium has been rotated. So its value has been dropped. The value has been dropped down. Now it will be re. This was the minus 70 millivolt. This value was what? Minus 70 millivolt. But when we count, so it has been arrived at minus 80 millivolt or minus 90 millivolt. 90 millivolt. So this is called hyperpolarization. This is called hyperpolarization. And this period is called refractive period. Refractive period. Got it? Now, I hope you will understand this lecture. If you find any doubts, please ask me anytime during the lecture. Okay? Thank you. Next lecture will be as our normal day. Got it? Thank you. Bye. Have a nice day. Okay. Bye.